the most challenging so far. It was well suited for OP. We'll see. Maybe we can challenge that assumption. Alright, so let's start reading this. You are already almost 1.5 kilometers below the surface of the ocean. Already so deep that you can't see any sunlight. What you can see, however, is a giant squid that has attached itself to the outside of your submarine. Being played on a set of boards is consisting of a 5x5 grid of numbers. Numbers are chosen at random, and the chosen number is marked on all boards on which it appears. Numbers may not appear on all boards. If all numbers in a row or in a column of a board are marked, that board wins. Diagonals don't count. The submarine has a bingo subsystem to help passengers. Currently, you and the giant squid pass the time. It automatically generates a random order in which to draw numbers and a random set of boards, your puzzle input. Now we have a lot of more information on a single input. After the first 5 numbers are drawn, there are no winners, but the boards are marked as follows. After the next 6 numbers are drawn, there are still no winners. Finally, 25 is drawn. The score of the winning board can be calculated. Start by finding the sum of all marked numbers on that board. The sum is 188. Then multiply that sum by the number that was just called. When the board 124 get the final score. So let's play bingo. Let's get the input here. We are going to start doing the same thing. So we have the input to evaluate something. Let's evaluate this. And we are going to do String.split. And we are going to split on new lines. We got this. There are probably some empty new lines, so we are going to trim them. The empty new lines are gone. We know that here is numbers. Those are the numbers, and here we have the boards. So let's parse those numbers. So the numbers are going to be String.split on a comma, and then we are going to convert all those numbers from a string to integer. We do have the numbers. Now we need to parse the boards. I'm going to model the boards as tuples of tuples. Using an X would be cool, I think, because we naturally get multidimensional arrays. We could use maps, but then it's kind of hard to traverse one particular thing. So I will try with tuples of tuples. I'm not sure if it's going to be the best idea, but that's the first thought that comes to my mind. So let's get the boards. So first thing off, we have all lines of all boards, right? So the first thing we want to do is that we want to chunk every 5 lines, and that's going to give us boards. And we want to map those lines. So why tuples and not lists? Very good question. If you want to do random access, like access something at a given position, the data structure to do that in Elixir are tuples. We could use lists as well and then use a numAt, but I think conceptually speaking, I would prefer tuples. Now we are going to get every chunk, which should be all 5 rows. Let's call it row them. No, it's rows. It's all 5 rows. Yes. So let's do another piping here. So for each row, it's a line, right? Row is a line. We want to split on comma again. Not on comma, it's on space. Yes, we want to split on space. And let's see what comes out of this. Rows. Okay, we are going to need to trim as well. So let's do the trimming. And now we want to convert this list to a tuple. So we have this list here, and now we want to convert this list to a tuple too. So now we have our boards. It's not nicely formatted as I thought it would be, but this is fine, right? So this is one board, this is the other board, and this is the other board, except we are missing a... Oh man. So this is a row. So many pipelines, inside pipelines, inside pipelines, inside pipelines. How is it? We live in a pipeline world. So we want to do string to integer here too. Maybe there's a way to reduce those pipelines, but this is fine. Well, let me think about this. I'm kind of feeling that maybe having an abstraction for the board is going to be good, because the issue with tuples here is that traversing the tuples to find if we have a number is kind of going to be annoying. If you do String.split without parameters, it already splits on all kinds of white space without a need to trim. Yes, you are correct. Let's do that, right? We want two things, right? We want something that goes from a board number. We need to know what are the numbers in the board, and we need to know which parts of the board have filled. The easiest way to know if something is in the board is by having a map that maps the board number, and then it needs to map to the position in the board. And then we need to know if that thing was checked. Let's create an empty board here. I'm going to create a struct. Let's pause this a bit for now. Maybe it's going to be a bad idea, but I think it's going to be worth it. So we're going to create a struct, and then it's going to have two fields, numbers, which is going to be a map, and it's going to have a board. The empty board is going to be duplicate. We want to have 5 things false. We want to have false 5 times. So the board is going to see which numbers were chosen. Then we figure out a way to. And then we want to do a tuple duplicate again of 5 of that. Okay, so I'm going to do an inspect here so we can see what I'm doing. But this is going to create the tuples of tuples the same. I didn't do an end somewhere. Line 32. Oh, okay, empty board. Actually, let me do this. And we're going to do board here at the bottom. We need to define on another. Okay, let's create another cell in here. And so you can see the board, right? So it's false, 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 and then we have the number. So here, all we need to do is to get all the numbers in the board and say to which position they map. So they're going to map to this row and they're going to map to this column. Let's do this. So when we create a board, let's have a new function here. We're going to receive the numbers, which is a map. We can do cool things like try to implement the inspect protocol for the board or something like that. I think that can be cool, but I'm getting a little bit ahead of myself. And then we don't need the board. We can say enforce keys, numbers. You need to pass the numbers when you create the board. So this should still be good. We want to know for each board, what are the numbers and their position. We want to do a for loop, right? So we want to go for each row and we want to have a num with index starting from 0. And then for each row, we want to get the column, which is going to be the string split of the row. So we want to put everything into a map. And all right, let's take a look at what is going to come out of this. So let's call this line and call this row. And then we have a number and call this column. So if we print everything we have so far here, we have the number, the row, and the column. Line is unused, you're correct. And that's an empty map because should Elixir have raised in here? I think it should have. We're not returning something that looks like a map. What am I getting wrong? Oh, we need to do with index. That's why I didn't raise, because we are not matching here as well. So now you can see that we have something that is the number, and that is taking us, let's see the first board. It does have 0, and it's saying it's at row 0, column 4. So this is correct. This is good. We just need to do string to integer. So those are the numbers. So our board is going to be passing this as argument. And we should get a bunch of boards. Let's see how this looks like. Okay, this looks good. We do have our boards with the numbers and everything. So far, so good. There are other ways we could do this. We could already pre-compute all the rows and all of the columns and their positions in the map. And then when we need to see if something is completed, it's kind of easy. Grid, I like that. It has a grade. Thank you very much. Does this still work? Okay, so we do have the boards, and now we want to go through the numbers, and for each of those numbers, I'm going to move this. Wait, so let's call these grids, because those are the grids, and with them we build the boards. And for each number, we want to go mark those numbers at the board, and then ask which board is complete. I'm going to use enum reduce while. That's going to allow us to go through the numbers, and then at the end, we can say if we want to continue or halt. We want to reduce over the board, so we're going to get the number, we're going to get the boards. Okay. If we return cont, and then I'll just return 0. So it should, okay, there is a line 43. Thank you. And boards is unused, number is unused, and return 0. So we are going to return a cont. I'm going to return number, so you can see it should return the last number. And is our last number 1? Yes, it is. So we are just going through things, and if we want to stop, we can say halt, and it should stop on the first number, which is 7. That's what reduce while does. We have control when we want to continue and we want to stop. We have our boards. We want to update our boards, right? So we're going to enum map, and then passing our boards. And for each board, we want to mark the number, which is already an integer. Let's say cont and have this return the boards. This is not going to work because we have not implemented mark. Now that we are having this, we could write unit tests, but the annoying thing with writing unit tests here is that we'll have to create the boards, which is a large fixture. I am procrastinating a little bit on the test, but that's something that maybe we can explore at the end. Mark, we are going to have a board, and the board is going to have numbers and the grade, and we're going to receive the number to mark. First thing we're going to do is, do we have this number? So I'm going to pattern match on the map. So does this map here, which is numbers, has a number as key? So we could use map fetch, we could use map get. I'm using pattern matching to see if the thing is there. I like using pattern matching a lot for this. And if there is a map, we are going to have a row and a column. We don't have a tuple update element. So I think let's implement an update element here. What this is going to do is that it's going to receive a tuple, it's going to receive a position. Oh, we can use access actually. We are going to use the Russian president function, but we are going to get the grid. And I think we have access element, and then we want to access the row, and then we want to access the column, and we want to store true. And that's going to be the new grid, and that's going to be the board. Something that we could do also is to remove the things from the grid, but let's skip this. We are going to say from grid. And then if we don't have a match, we just return board itself. I'm going to use the update operator here too, because just in case. Oh, we don't need to update the numbers are the same, so we just update the grid. If we want to be fancy, we could even do this, and then we just pass the board. And that's going to get the board, it's going to get the grid in the board, get that row, get that column, and then so on. Okay, this is our mark function. We don't have the board. We're not storing it anywhere. We are not using the grid. Thank you, compiler. This is all good. Board get and update is undefined. Oh, yes. It's a struct, so we're going to use, we want to access the field grid. What am I doing wrong? Is it not field? It is field, right? Let's see the docs. Or there is no field function. Is that key then? Okay, all right, that answers all of it. This one, everything is true. This one, everything is true. So maybe all the numbers are being filled, and that's why everything is true. I don't think that's the case. Could that be a bug? How many numbers do we have? It's because we are going to the end, right? We are never stopping. So it would make sense if it's going into the end. No, what I want is the length. So let's do this step, and then we're going to get the length. And I have a typo somewhere. 27. Okay, that's going to cover everything, right? If we don't have anything more than 26 here. Goes into 25. Why we have 27? Oh, 26. Okay, and starts from 0. All right, we are good, yes. So all boards are going to be good if we don't stop. Great. So now we need to see if the board won. Did a particular board win? To do this, we only need the grid. We are going to say row 1 on the grid or column 1 on the grid. For row 1, how are we going to implement this? We are going to have the grid. So from 0 to 5, because we know what is the, from 0 to 4, we know what is the thing, right? Do we need to do another one? If a row 1, I'm going to pick this row, and then I need to traverse everything. I'm going to do the non-efficient version. I need to see if everybody in there is true. Okay, so let's call this row. If we get the first row on the grid, and if it is, I'm just going to do this. If it is this, actually, so we want to check if there is any row on the grid where that row is all true. So we got a row, and then 0, if everything in there is true, we are good. Okay, and column 1. Grid. We need to do the same thing. So for a column, let's go by part. So we need to traverse the rows 0 to 4. And then for each row, we need to access a certain position in that. First, we need to access all the zeros in those tuples or all the something else. I am struggling a little bit with this one. No, we don't want to do this nested. I'm struggling with this. And then for each row, let's see how this is going to look like. I'm going to put an inspect here, and then we're going to get some feedback. And so what we want to do is that the grid, the first thing that we access on the grid is the row. So we're going to do this grid. We want to get this row, and then we want to get this column. If this is true, and we actually want to know if for any of those, no, all of those. I chose a column, so I go through all rows, and we want to know if all of those are true. I got it. I think I got it. We want to see if all of those are true. And we want to see if any of the columns are true. I think I got it. Pick a column, 0, and then we're going to go through all rows and we check if everybody's true. Since this is true or false, I actually don't need this equals true in here. We can go for a little bit. Yes, okay. This is it. It's just that here we just checked equals tuple because it was much easier, but here we need to traverse on the other direction. But I think this is it. Let's see if we can find a board that won. If we can find this board, we want to return halt and the board. Otherwise, we continue with all the boards. We get a board here, so this should be our winning board. I'm going to pattern matching here to make sure that we are getting a board at the end and we are not getting the end of the traversal. The third board wins with 14, 24. It's the board with 14 at position 0, 0. Let's see if that matches. 14 at position 0, 0. Okay, we are good. The score winning board can be calculated by finding the sum of all unmarked numbers on that board. In this case, the sum is 188. Then multiply that sum by the number that was just called when the board won, 24. Okay, so this is easy. I actually like this because if we need the number, we are going to return it here. So here we get the number and we get the board. So now we have both. We have the winning number and the board. We need the sum of all of the not drawn positions. So we are going to have a new function here, which we are going to call unmarked sum. Since we are going with mark, unmarked sum, this is going to receive the board with the numbers and with the grid. The easiest way to do this is to go through all the numbers. So this is going to be the number, this is going to be the row, it's going to be the column. We're going to go through all the numbers and we're going to see, hey, does accessing the grid, so remember we can do grid row and then so we're accessing the tuples. Is this false? Because those are all the numbers that we want. If it is, we return the number, and what we want to do is the sum of this. We could sum as we traverse. I'm not worried about that. The boards are small. So our result should be the number multiplied by the board unmarked sum, this, which is wrong, very, very wrong. No, it's correct. This is part 1, and I want to move this to an input, and for that we need to install Kino. Jonathan just released a new version, so we're going to use this new version. And we are going to create a field for the input in here. So we're going to do Kino input text area and please paste your input. We can render this. So now we are going to get this input here. We are going to put it here. We need to change the code. This is now input. Let's pipeline this all the way. Kino. Oh, I forgot to assign to a variable, right? We want to read the input and then we want to pipe this. And I need to assign this to a variable. I think we should be good still. Nope, undefined function input. Oh, I need to re-execute it, of course. So it's all good. I basically moved the input to this cell here. We can change the input and re-evaluate the cell, but we can always mark a cell automatically re-evaluate. Now, when we get the actual puzzle input and we put it here, it's automatically going to compute the new result for us, which is here. So let's submit this. It works. Part 2. On the other hand, it might be wise to try a different strategy. Let the giant squid win. You aren't sure how many bingo boards a giant squid could play at once. So rather than waste time counting its arms, the safe thing to do is figure out which board will win last and choose that one. That way, no matter which board it picks, it will win for sure. In the example above, the second board is the last to win. Okay, there is a bunch of things that we can reuse here. So I'm going to move all this to setup. There is more to share as well. Let's keep everything here. Let's share this as well. I'm going to move this up. So we want to copy, no, this needs to come after the board. So this is here. I'm going to get the board and put it here. So we get the input here. We get the board definition here. This is all good. And then this is the initial parsing. We don't need this anymore. So let me kill this. And we want to do an initial parsing of the numbers as well. Let's share that. Let's parse the numbers here. And now we just want to do the reduce while on the numbers over the boards. Numbers doesn't exist. Let's evaluate everything. Wait, I should have evaluated this too, but it's the same, this is the same. Let's just make sure that everything is evaluated. Okay, we have changed things so we can reevaluate the code. I just organized the code, moved everything that is going to be shared between part 1 and part 2. So now we should still have access to everything in here. So we do have all the numbers, we do have all the boards. As in the previous day, I'm going to roll back the input because we want to test these on the original input first. Let's come back here. So we're going to do the same thing. We're going to do a enum reduce while. We are going to start with the numbers. We are going to start with the boards. But now we know that for our condition, we want to stop at some point. When we have only one board left, most likely need the draft number still. So when we get a number and we have only one board left, which means that we have only one element in the list, we want to do halt with the number and the board. Same thing as before. Otherwise, you're going to have the numbers and the boards. I'm going to copy and paste the code. Oh no, this can have an issue. I'm sorry, this is not good. Do it differently. This could have an issue where if the board wins on the last number, it would not be called. It's not good. So we are going to mark all the boards as before. We want to remove the boards that have 1. Let's do a pipeline as one usually does. Oh, let's do just one weird pipeline. So we want to reject all the boards that have 1, and then we want to pipe that result to a case. If we have a single board, then that's the last to win board. If we have multiple boards, we'll continue. So very similar to the one we had before. Do we still need to do the same thing? Get the number, get the board. I'm going to copy and paste because I'm lazy. We could even refactor, I think, maybe, to share more of the code. This is it. I forgot to pipe. Okay, we go for the boards, we mark. If the board has 1, we reject it. And then if at the end we have only a single board, that's by definition going to be the last one to win. And our result was 2576, which matches. No, it doesn't match. Okay, the second board is last one to win, which happens after 13 is eventually called and its middle column is completely marked. If we were to keep playing until this point, the second board would have a son of a marked numbers. The last board still needs to win. Do I need to go until the end until it wins? Is that it? So how are we going to do this? When this is an empty list, we are going to assume that we had only one board left, because otherwise, if we didn't have only one board left, it means that we have 2 boards winning at the same time, and then I'm going to assume that advent of code is wrong. It gave me a bad input. Let's do this, and it still doesn't work. 1924. Let's break this down a little bit. Let's see what we are getting. We are getting 13. Oh, it's because we are not marking the number that won. Okay, that makes sense. Blame the pipeline. Let's undo the pipeline. And then we are going to reject the boards that won. So these should be good. We pass the boards here. What is the final result? Okay, we got it. This is good. All right, this is correct. So now I need to get the input and we're going to be done with this and we can do some other cool stuff. So let's update the input. So this should be my result. So I submit it and it's all good.